This is the third introductory video related to MATLAB, leading up to me sharing a number of thermodynamic property system tools with you that you might consider learning how to use in MATLAB to improve your effectiveness. But what's behind the brains behind all of the files is a single built-in function in MATLAB called Interp1. And so what I want to do is just give you a little demo of how the built-in function Interp1 works to introduce the idea that's coming up. And so this has to do with just linear interpolation in the MATLAB environment. So this little image should look familiar to you, I hope. Given two red dots at x0 and x1, you know y0 and y1, those are all known, they're tabulated. But your assignment, your problem needs to find out what is y at the coordinate x, which is in between 0 and 1. So I'll bet you at this point you've gotten pretty good at this. Well, let's look at what MATLAB has to offer. Okay, practical problem that for those of you taking thermodynamics, I hope looks kind of familiar to you, right? Determine the internal energy little u for H2O, steam, for a pressure of 150 kPa and temperature of 305. Now, if you were given 150 kPa and a temperature of 280, that would be really easy, wouldn't it? You just go to your superheated vapor table, you'd find 150 kPa pressure table, and here's 280. I'll just look over here in the U column and I'm going to write down 2778.6. I'm done. Woo, great. That was an easy homework problem. Homework problems aren't turning out that easy all the time now, are they? Because you're finding that you're needing to find the internal energy U at some strange temperature that's between 280 and 320, or in other words, 305. And so what you do is either you go to your calculator work, you've got something built into your calculator, or preferably you write down pencil and paper, you write down a little table on your own and visually see, I'm looking for this value, and how will I get this value? Okay, well, so here's the little table you wrote down, and you can either memorize a formula or you could code a formula into your calculator and maybe not really know what you're doing. Or you could kind of create a formula in your head to really learn what's going on. So you know that U is at least this much. So we're in between 280 and 320. We're at 305. So it's at least this much, and it's going to be less than that much. You know it's going to be that. And so if you think about proportions, you can sort of derive the formula in your head and numerically evaluate that here's the proportion, 305 minus 280. That's the numerator. The denominator proportion is 320 minus 280. So for this case, we've got 2778.6 plus 25 over 40 times the difference between these two U values. And however you get the number, the U value is 2817.4. So, okay, I think you got it. It probably takes you a little bit of a time to do this when you're working through your homework problems. So what I'm leading up to is sharing with you some MATLAB tools that I've created for you and for myself, my own use in interpolating in between values in steam tables, air tables, and refrigerant tables. Okay, so it's my assumption that you have taken or are taking ME 2004, called numerical analysis, but my best understanding is that it's heavily weighted in learning how to use MATLAB. And so so I'm assuming that you've either taken or are taking MATLAB, so you're kind of familiar with some of the basics of MATLAB programming. All right, so here's a practical problem that I'd like to illustrate. Here is my, I've circled it. I'm going camping on a mountain and I want to plan for cook time. I'm boiling something. I want to plan for cook time. I'm going to go to Mount Rogers in Marion, Virginia, and I know that that's got an elevation of 5,729 feet above sea level. And I need to determine before I go camping what will be the boiling point of water on top of Mount Rogers. So that's my practical problem. And then also think about creating a tool. What if you go camping a lot in different areas? And so you got to do this planning from time to time throughout the year at different elevations. I hope you're getting the idea that, man, if I could create a tool, a repeatable tool, I wouldn't have to do the same thing over and over again. All right, so then the next thing I did was, with my practical problem, I went to Google and I somehow Googled, I said, a boiling point of water at different elevations. And here's the result I got. I got feet above sea level. Here's those numbers and the corresponding boiling point in degrees C, those numbers. So I just downloaded those from Google and here we are. And I've entered that in, as you can see, in my MATLAB solution. So let's go live and look at MATLAB and show you how I did the solution and how I used. So the point of this video is not necessarily determining the boiling point on top of Mount Rogers, but to illustrate how do we use the MATLAB built-in function interp1, and how do we do that over and over and over again. All right, here we go. All right, so I'm going to minimize my PowerPoint. I'm going to go to MATLAB. I have loaded in my interpolation demo problem. Okay. Oh, I see I've still got problem solving recipe loaded in from previous video. Let me close that out. All right, so we've got interpolation demo loaded, and here was my practical problem. Remember, documentation is critical, and so in this one, I'm saying what my file name is here in a comment. I'm saying I did this work on what day I did the work, and I've typed out the practical problem, and up above that, I'm also kind of showing the result of my Google work to get elevation and boiling point data pairs. Okay, so I think you got it. So now here's my solution. Here's my my clearing functions in MATLAB. I don't really fully understand why, but I know it clears out the command line and it clears out previous variables. See how I'm showing now in comments, I'm beginning my solution. So visually, it becomes clear where the solution in MATLAB begins. All right, so I'm describing, first thing I'm going to do is define my X vector, the elevation vector, the set of numbers that describes elevation. I'm calling it LEV above sea level equals in brackets, and there's my numbers. All right. The next thing is to define the Y vector. You see the similarity between this and steam tables. I hope you do. Define the Y vector, boiling point in brackets, and there's my boiling point. So the number of entries in elevation above sea level has to exactly match the number of entries in boiling point. Okay. The next thing I'm going to do for my upcoming camping experience, define the elevation, 5,729, and I've written out feet. Okay. Well, now we're ready to go. We've almost built our tool. I'm going to use the built-in function offered by MATLAB called interp1. Now, I've only been at this MATLAB business for about 3 weeks. So I had to go out to, I looked at some other graduate students' work that we were working collaboratively a couple of years ago. And I noticed he was using a function called interp1, but that's all I knew. I didn't fully understand how it worked. I went out and found some YouTube videos offered by MATLAB and their website and learned more about interp1. And that's how I learned what the syntax was using interp1. So here's what I want to do is I want to calculate the boiling point. I'm going to call it boil temp, okay? And I'm going to use the built-in function interp1. and I realized after doing my reading, watching the video, my X vector's got to go in first, elevation above sea level, that's the X vector. The next thing that goes in is the Y vector, boiling point vector. And then the third thing that goes in is your independent variable, what your X value is. So we've got X vector, Y value, and your single value for X, and the return is going to be Y, the linear interpolation, just like that pencil and paper I showed on the PowerPoint slide. Okay, and so boil temp is what's returned, interpolating between in these two vectors for elevation. So I've got a number in boil temp. That's going to be in degrees C. And look, in my world, in the USA, most of my units are in, my temperature units are in degrees F. So I'm going to, in my MATLAB, I'm going to convert degrees C into degrees F by saying a new variable, boil temp F, that's a new variable, boil temp F equals 9/5 times boil temp plus 32. That's just the conversion of degrees C into degrees F. You'll see that in my work, I suppress all my calculations up here in MATLAB until the end, and I prepare my numerical outputs for the command window. So I say line prep, demo of MATLAB built-in function. That's what we're doing. I've got a line prep of just a sort of a dashed line as a divider. Next, I'm creating a string, a long string that says H2O boiling point, changing boil temp into a string, into text, with the units degrees C. I'm going to display that line prep. Next line prep again, H2O boiling point. I'm going to change my variable name boil temp F into a string text, and then label it degrees F at, oh, what else have I got? Oh, there we go. I added in my line prep feet above sea level. So let's see. So it's going to run. I'm going to click the run icon. And there is my command window result as I'm planning my camping trip. My boiling point is in degrees C, 94.52 at 5729 feet. It's also 202.14 degrees F at 5729 feet above sea level. Does that make sense for everybody taking thermo? I'd say it does. So at 1 atmosphere at sea level, you know that the boiling point is about 100 degrees C or 212 degrees F, and we've got a numerical result of 94.5 degrees C on Mount Rogers or 202 degrees F. So that tells me what I need to know. That'll enable me to maybe calculate my boiling time if I'm making pasta while I'm camping, to adjust for a little longer boil time because the boiling temperature is lower than it would be at sea level, let's say per a recipe. Okay, so let's see. That is a simple demo of linear interpolation. Now, it turns out that Interp 1 is extraordinarily powerful if you know how to use it and you use it over and over again. Let me show you how to get to this MATLAB file if you're interested in simply using this as a little bit of a template, self-teaching yourself, or using it to save as a tool, standalone tool, or extend it with something else you have in mind. I'm going to go to my browser, and we're at Jay's Toolbox website. So let's see, it's jaystoolbox.vt.domains, my public website. So let's scroll, let's bring down, I'm going to go to Toolbox menu and go to MATLAB. And the single page is my entire growing library of MATLAB files that I offer for anyone to download and use. Let's keep scrolling down. And there it is at the bottom of the page. Interpolation demo MATLAB. You can download this file. Let me click on this file here. Okay, so there's the page. And so one thing to be aware of, that all the files that I've saved back, I'm going backwards, all of the files that I've saved in this library are saved as .doc files, .doc. They are ASCII files. So when once you download this, you can open it in your in either Word or preferably in Notepad, and then save that file to .m file type, so it becomes a MATLAB file. And that's part of the beauty of MATLAB programming files, is they're stored as ASCII files, flat files that don't have special characters, special commands that are platform specific. So that's a real advantage of MATLAB script files. Okay, let's see. So let's go. I'm going to go back to PowerPoint to be sure we're finished up. Okay, so we covered this interp1 built-in function in MATLAB, talked a little bit about documenting your work, be sure you got a good documentation, and just showed how to download this particular file. And just remember, the run icon is what gives you the nice, pretty output in the command window. So that's it. That's a demonstration of interp1. But now, once we've gotten through these 3 introductory videos, now I'm going to really be able to offer you some powerful thermodynamic property lookup tools that will enable you to look up thermodynamic properties at those in-between values, the values that are in between the tabulated values. And so it's my hope that those tools are going to help speed up your ability to look up thermodynamic properties and solve thermal heat transfer fluids problems faster, as long as you have a good fundamental understanding of what's behind the properties and what's behind the thermal systems problem solving. Hope that helps, and stay tuned for the launching of these thermodynamic property MATLAB tools.